Sam and I are going to give you a live demo of some of the things you can do with Git to sort of follow on from Sam's talk. We're going to be using the basic hello world file from LaTeX as the example. Well, I think it's just basically a test for a hello world one, whatever we've got in the repository, but it's very basic. So just so you get a little bit of idea about LaTeX and version control as well. Sam and I are going to get a bit conflicty later on, but don't worry, it's mostly fake, isn't it, Sam? We like each other, really. So I'm just going to share my screen. Right, hopefully this is going to work. This is the advantage of having two computers. I can see that it has in fact worked because it's on my other computer. Always good for Zoom events. Right, okay. So I'm just going to run you through a bit about creating a GitHub repository using the web interface. And then I'm going to pass over to Sam, and we're going to sort of talk you through some of the different basic Git commands. We're going to show you how to make a repository. Sam's going to show you how to clone that repository and to do all the different Git commands with that. We're going to show you how to hopefully resolve a conflict, and we're going to give you a bit of a talk about branches as well. So let's assume that Sam and I have decided to team up to work on a LaTeX project together. And we've decided that we don't want to use Overleaf because we haven't yet listened to Nikki's wonderful talk about why it's so amazing. So we're currently ignorant to that. And we are going to use GitHub to version control our fancy LaTeX report that we're going to write about something. So step one, I need to create a repository. I've decided to take charge of that. So I've logged into my GitHub account. I'm on the main page, and I'm going to click this nice new repository button. So now I'm going to come up with a nice repository name. Unfortunately, we had to test this the other day, so Skills4Scientists test is already gone. But we're going to come up with a really, really inventive Skills4Scientists test 2. Very exciting. It's going to give it a quick description. Now, I've got an option to make my repository public or private. If you guys are working on your own coding projects that you don't want anyone else to see yet, or you're working in industry, or you're collaborating on something secret, then I would recommend that you use a private repository. If you are looking to do something where you're looking for lots of people to come in and get involved, or you don't mind if people look at things and see how it's like going as you progress, and particularly if you're trying to make something available like we are doing here, then you want to go public. Normally, I think you can make, they might have changed the licensing rules now, but normally you used to be able to have 1 or 2 private repositories with a regular GitHub account. If you have an academic account, you get access to unlimited private repositories, so that is really useful. You can also switch between them. So say you might decide to have, say, I don't know, your thesis or your PhD as private, and then later on you want to share it, you can then switch that afterwards. Or you can always just make a new repository with the shiny, tidied up documents, which is what I did for my PhD. So we're going to go public. Now we're going to tick add a README file. README files are important. They are basically the window into your project. If you are making, to be honest, even if you're making a public repository, if you're planning to share it with someone, you should have a README file so that they know what's going on. But particularly if you're doing a public project, you intend for other people to come and actually download things from your repositories, have a README file. That README file should explain what is in your repository. And particularly if it's something like LaTeX report, it might tell you what that report's about, what's going on. If it's a coding project, it will explain to you how you should get everything up and running, if you've got any particular installation instructions. So we're going to add that. We are also going to tick to add a Git Ignore file. Now, a Git Ignore file basically tells Git, I want to ignore these certain types of files with these certain file extensions. So as I mentioned in my LaTeX talk, when you compile LaTeX, you get a ton of different auxiliary files. Similarly, you might notice if you have a Mac, you often get those weird .ds store files or those random hidden folders. We don't want any of those coming into our nice shiny GitHub repository. So we're going to have a Git Ignore file. There are thankfully lots of templates for this. So as you can see, they've got lots of templates for different types of code, depending on what you're writing. But if I keep going, they do also have one for LaTeX somewhere. Definitely, there we go. So we're now going to give it our LaTeX Git Ignore template. Now you can also choose a license. We're not going to do that now because this isn't code. This is just a test repository, but if you were making something available, particularly if it was code or materials that you wanted people to be able to reuse, then it's good to add a license, because then that tells them what they can and can't do with it. So now I've set all of those instructions, I'm going to create my repository. Fantastic. So we now have the repository. Now I might want to add some files to this. So I'm just going to show you how to add a file via this interface, and then Sam will show you later what you can do using the command line interface. So I just want to add a file, and I'm going to upload my little test.tech that I created earlier and did have in a handy folder, and of course now it's disappeared, so bear with me. There we go. And now I have added this in here. Now I'm going to add a commit message, which is important. You should always have good descriptive commit messages, because if someone comes and looks at your repository, or if indeed Sam and I are working together on the repository and he pulls my commits, he should know what I've done. So me just writing blah, 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 or leaving it blank is not remotely helpful. And that might cause us to have other types of conflict. So I'm just going to put adding. So now written my commit message, and then I'm going to commit the changes. As you can see, there's an option for me to commit directly to the main branch, or I could create a new branch for this commit, but as it is, we'll talk to you about branches at the end, but I'm just going to commit directly to this main branch. Right, so that's now in. Now I need to add Sam to my repository. I mean, don't necessarily have to, it's public, you could come and clone it, but I want to add him as a collaborator. So I'm now going to find the bit where I add him, which I literally did the other day. I'll manage access, there we go. Now, oh, I really hope I remember my password. There we go, and we're back. Great, invite a collaborator. So I happen to know Sam's details, so I'm now adding him to this repository. So Sam, you should now have my invite.
Right. Sammy Kanza has added me. If I view the invitation.
So now I'm going to stop sharing, and Sam is going to show you what's going to happen on his end.
Okay, so let's share a screen. Let's share this one. Great. Can you see Sammy's that Sammy has invited me to her to collaborate? Sorry, forgetting all my words here. So Sammy has invited me to collaborate, and I will accept this invitation. And what I want to do is I want to clone this repository. So here I go into this code part, and I will copy and paste the whole thing, and I will go back to my terminal. Oh, hang on, having some problems. Let me just stop sharing for a second. Copy that and open my terminal. Which is here. So if I start sharing again. Okay, can you guys see my terminal?
I can certainly see your terminal.
Fantastic. So using the same format as before, what we can do is we can say git clone, and then we paste that link that we got from the invitation that Sammy sent us. So if we run this, we can see that I'm cloning it into this folder that I've already made on my desktop, but you guys can do this anywhere that you like. And it comes up with some more information, enumerating some objects, counting some objects, compressing them. This is all just information about what is in this repository and the things that it has to do so that you can access them. It's not really super important unless you are really worried about how big the repository is or what might be in there. So what I want to then do is I want to
CD into the folder.
Yes, I want to change my directory into the folder. So where has it gone?
Skills for, yeah,
There it is.
middle column.
And we can see that if I just change it, we can see that in here there is test.tech and a README file that Sammy has just made. So if we go git status now, we can see that our branch is up to date with origin and main, nothing to commit, working tree clean. So this is what I was talking about in my portion of the talk, where we are on the main branch, the master branch, and everything right now is completely up to date. So now I think, Sammy, what I need to do is I need to make some alterations to our test file.
Yep. So now, for some inexplicable reason, I've handed over some responsibility to Sam, and he is now having to add something to our text file. And so, this is our basic hello world document for Sam to add to.
Yeah, and just as a comment here, all I've done is I've used something called the Vim Editor, which is just a text editor that comes with the terminal, which allows me to very quickly go in and edit something in this document. So we can see that it's set up like a LaTeX file because it's a text file, and it says hello world, and I'm going to add hello Sammy, I'm here. And what we're going to do is we're going to save that. And what that's done is that's updated that text file with my edits and changes. So, Sammy, do you just want to say a little bit about the ignore files and things like this, or?
Well, so I was going to say, now you might think that what Sam should do next is that he should commit his changes, but that is not what Sam should do next. Sam, what should you do next?
Well, what we should do is we should have a conversation about the changes that I've made, and I need to also compile this text file. So I have LaTeX on my machine, so I'm going to compile this text file. And again, it comes up with some information that is related to the text file and how it's being compiled. It gives you some information on the class of document. Some of the eagle-eyed in you might have spotted that it's an article. And it tells us about some of the outputs. Yep, go for it.
So if Sam does an ls-l, now you can see that we've got some additional files. So we have the PDF file, which we definitely care about and we want to commit. We are going to assume, for the purposes of this demo, that Sam has diligently gone and looked at the PDF document and checked that it does in fact look like he thinks it should look. So first point is Sam compiled his code. Well, Sam compiled his LaTeX code before he thought about committing, which is really good practice. Both for code and for LaTeX, you should never, ever, ever just randomly change things and push it back to your version control. Your teammates will hate you. And to be honest, if you do it on a solo repository, you will hate you because that's just not the way forward. The problem is if you're working on anything that has any sort of codependencies, I mean, obviously you don't want to push just a random one broken file, but if you're working on a big coding project, if you change something in your code and you haven't checked that it works, that everything still compiles, you can easily break the entire project. And that can go really, really badly. There are other mitigations to this, which we will talk about later in terms of branching and sensibly going off and doing things separately and checking them before you push them back into the main branch. But as we're currently working on the main branch, just remember, whatever you do, test it, check it, compile it. If you're working on a big programming project, you might have automated tests. Again, it's always a very good regulation to run all of those before you commit. If you're working for a coding company, you might have certain procedures in place that you must do before you commit to version control. One of the ones I worked in, we had to run every single automated test and we had to get a green light for all of them, or we were not allowed to commit. So just really important, off my soapbox now. So Sam has compiled, that's really good. We can see that from his compilation, not only have we got the PDF file, but we've got a .aux file and a .log file. Those auxiliary files that LaTeX creates when it does its compilation. However, we do not want to commit those to our repository, which is why we had our Git Ignore file. That Git Ignore file was using the text template, so it will actually have .log and .aux listed as some of the files it should ignore. So I'm hoping this is going to work. But Sam, if you do a git status.
Yep.
So as you can see, it shows that Sam has modified test.tech, and it shows that Sam has now added, technically by his compilation, test.pdf. However, it does not show the test.awk or the test.log because it automatically knows it needs to ignore them. So that is the wonderful beauty of your Git Ignore file. There are tons of templates out there. As you saw, GitHub had a load of them, or there are example ones you can Google for, and they're quite easy to make as well. It's just literally a case of listing all your commands. So Sam has now compiled. We're going to assume he's checked his PDF, and he has now gone and checked what has been edited. So now he's going to talk you through the commit process.
So it's exactly the same as what we did in the last session, but I'm going to introduce you, or Sammy and I are going to introduce you to a slightly different way of doing things, because what we want to say is we want to git add, and then we want to just add everything, because we have our git ignore files, so we know that it won't add the things we don't want it to add. So to save us time, we can just say git add star, and this star just means add everything that is allowed to be added at the moment. So I run that, and as Sammy has said, the following paths are ignored by one of our git ignore files, the test.awks, test.log. So we know everything's working well now. Now all we need to do is we need to say, right, I want to commit this, and I want to say Sam's edits to the file. Oh.
Again, Sam's giving me a good descriptive commit message, which is really important. So when I pull his changes, I will know what he's done.
Absolutely. And this is exactly the same as what we saw in the last session. And you can see that there's been 2 files changed, 3 insertions and 1 deletion. So the next thing we want to do is we now need to push it so that so that our collaboration can continue to work well. So if we say git push, and it's again come up with quite a lot of information about what's going on, and we can say that, and we can see that it's gone back to the repository on GitHub that it's aiming at that Sammy made earlier.
So now we have done that, unfortunately, in our project. Now, normally we did talk in our research data management, in collaborative data management, that one of the main things you should do with your teammates is communicate. And good communication can help you get out of a hell of a lot of issues. However, Sam and I have had a fight, and we have decided that we actually don't really want to work together, but we're stuck working on this paper, and we're both ignoring each other, and we both decided that we're just both going to go edit the file now. So we're just going to both go quickly, go and edit the file without telling each other. And Sam, don't push yours.
So let's go back to, I've got a terrible memory and I've forgotten what it's called already. There it is. So I've made my changes.
And I'm just making mine. Now, unbeknownst to Sam, I am cheekily adding my changes without talking to him and without us having agreed that I'm going to do this. Hang on, I'm just getting that going. Right, so I, unbeknownst to Sam, have now changed test.tech as well. And I have actually got in first and I've pushed it to the repository. So if Sam now tries to commit and push his test.tech, we should, assuming we've done this right, get a conflict.
So first of all, I'm just going to look at Git status as we always do. And yep, nothing really too out of the ordinary there. Now I'm going to add my updated file, and We can see that it's not come back with any problems, so we've added it. So now I'm going to say git commit as before, and my message, I'm not telling Sammy I've updated this. Okay, so we've committed it, and now we need to try and push it back into our repository. Aha, we have a problem.
So I just want to make a point here that obviously what Sam and I are going to show you in terms of resolving this LaTeX conflict is obviously quite simple because we've deliberately given you a simple document. But just to harp back to what I said in my collaborative data editing talk, you do really want to think about whether there are things you want to be collaboratively trying to edit at the same time. And typically, if you're using something via version control, you do not want to be both editing it at the same time. We have both made simple changes and we're going to show you how to clear it up. But if you had a large text document and you both made loads of different changes in paragraphs and text, if you've got a large code document, that is going to be an absolute nightmare to fix merge conflicts with. So we are going to show you how to do it, but your best bet to resolve your conflicts is to not get into them in the first place. And you can fix that by not doing what Sam and I have done and randomly deciding to change the files without talking to each other. So now, in order for Sam to do this, he needs to do a Git pull. Now, actually, what he should have done is he should have done a Git pull before he did any committing in the first place. This is something else you should always do. So before you commit your changes, you should compile your code and you should check what you've done, but you should also always do a pull. You should always know that your repository is up to date before you then try and commit things. So, but we didn't do that. So we're going to press on. So now Sam is going to do a Git pull.
So we'll say Git pull.
And now we can see that we have this merge conflict in test.tech. So we need to figure out what's happened. Clearly, we both edited it at the same time. So now we need to have a look at the document and, say Sam and I, we've now panicked, we've spoken to each other. Let's both look at the document, figure out what of whose changes we're going to keep in. So now Sam can do a git diff. So as you can see, we have good luck dealing. There wasn't that meant to be good luck dealing, Sam.
It was meant to be good. The pressure got to me.
Well, clearly.
The anger was just
the anger,
got
right.
to me.
So as you can see, we can see that you can see the general bits of the document that didn't change. You can see my change and you can see Sam's change. And you can see those sort of equal signs and lots of back arrows and forward arrows to sort of highlight where the merge issues are. So Sam and I have sort of tentatively made up and we've agreed in the interest of moving forward that we are going to keep both of our changes in the document. So what Sam now needs to do that is he needs to go and remove the markers around all this and just put it back to looking like a regular document that doesn't have any merge information in it. Obviously, the main thing you do always need to do here is to remove the merge information and make an agreement of what you're going to keep. He could remove my changes, we could remove everything, we could put new stuff in here, but generally we're just going to decide to keep both things. So Sam, if you can go in and remove all of that stuff.
Okay, here we are. So let's get rid of everything in this file that we don't want, but we do want to keep both of ours work. And we'll get rid of this code to say that there has been a change here as well.
Yeah.
Okay, so I need to save this. Right, now if we run a git status, we can see again that there's work to do here to make this to make version control track it and to get it back onto the collaborative world that we're working in. So we want to add it. We want to commit it
with a good message stating that we are fixing the merge conflict for anyone who comes in and looks at their repository.
Merge conflict and our friendship.
Aspen, as for your question, the commands that we use, so Aspen has just asked, what did we do to save the file? It looks like :wd exclamation mark. That is exactly what you do. In VI, you can have insert mode, which is where you click on the I, or you can get out of it using escape, once you're in your command mode, then you can do various different commands, and the letters mean different commands. You use colon to get your commands, W means write, and your exclamation mark means save.
And what I was doing there was I was doing WQ exclamation mark. Q that's just a shortcut to saying W, write it, Q, then quit it, and the exclamation mark just means save everything.
So that's just a couple of different commands you can do on VI. It's actually a really nice, powerful text editor. It just, again, involves kind of a learning curve, much like LaTeX, to get around it, but particularly for making short documents in the terminal can be really cool.
Okay, and then what I need to do is I need to push this back to Sammy, and we can see that it's resolved a lot of our issues.
So just to make a point, Sam's obviously done all of this via the command line. You could do this via a GUI as well. So you could do things via the web interfaces I showed you, but there are also specific GUIs you can download. Certainly for Windows, I assume they exist for Mac, but I've never downloaded one. But because I quite like the command line, but there are ways you can do all of this, and you don't necessarily have to use this command line interface if you're not comfortable with it.
However, having said that, and I think Sammy will agree with me here, using the command line is a lot faster.
Yes, definitely.
A lot more powerful.
But I think, Nikki, maybe if you could put in the chat the name of the GUI you said you used, because that's one for Windows. Yeah, she'll put that in the chat. So now we have shown you how to resolve a conflict and how conflicts can come about. And as I said, ideally, you would not end up in this situation. Now, something else you might want to do is you might want to branch off and work on something specific by yourself or in a smaller sub team, and you don't want it affecting the rest of the code or the document. So we talked about dependencies, and what Nikki is going to tell you later on in her overleaf talk is that you can actually split up LaTeX into lots of different chapters and import them all into one master document if you want. So let's say for this example, we've decided that Sam and I are actually going to write different chapters, and I've decided that he can't be trusted, and I'm going to send him off to write his own chapter by himself, and I'm only going to load it back into my beautiful LaTeX document once I've approved it. So for that purposes, we are going to set up something called a new branch. So Sam, if you could make a new branch, that would be fantastic.
Sam's branch.
So this means that Sam can now go ahead and work on a separate set of files. When he commits, he'll be committing to his branch. So he's essentially got that own sort of self-isolated bit of his own version control. So he could work with sub-team people if he wanted. We could add Nikki in, and Nikki and Sam could both work on the chapter. But it basically means that whatever happens in his branch is not affecting the main branch, or I could also branch off and do other chapters somewhere separate. But until we make the decision to bring it back into the main branch, it is now separate and isolated and will not be affecting the main branch. I've got to be honest, this typically isn't used for LaTeX documents, but we wanted to show you how to do it. It is really, really often used in good programming practice, because if you want to go off and work on a particular new bit of functionality, nobody wants that messing up the main branch. We've just shown you how easy it is to cause merge issues and conflicts, and how you definitely don't want multiple people to be working on things at the same time. So normally, in good practice, you'll be sent off on a branch by yourself or in a subgroup to work on a particular change or a particular bit of functionality. And once that's been reviewed and checked and tested, then you'll be allowed to go back into the main branch. So Sam has made his branch, and now he's going to check out his branch, which means that now he is switched to working on this branch. So everything he does, all the files he accesses, all the Git commands, the pushes back to the repository, they all now work via this branch. So he is now going to create a new tech file.
Yep. Tech file 2.tech.
So if we git status that, we can see that that is now existing in Sam's branch. And now we're just going to briefly show. So we're now going to assume that Sam has filled that full of his perfect chapter. I've reviewed it, I've said it's fine, and we're now all ready to merge it back into the main branch. So he's going to commit the file.
I will compile it first.
Oh, yes, you will compile it first.
Yep. Because as Sammy said earlier, always compile it Otherwise, lots and lots and lots of people, including yourself, will be very unhappy.
You haven't put anything in it.
I've not put anything in it. That's why. Okay. How do we get out of here then?
Is it Control C?
Yeah, that's not working. Okay, we've got a bit of an issue. The problems with live code alongs.
Always.
Oh, X to quit. There we go. We've quit.
Okay,
so,
we're going to pretend that Sam has compiled this.
Yep, pretend that I've compiled it. So now we need to add it. We need to commit it. Sam's chapter. And then we need to push it.
So now Sam has pushed that locally to his branch, and that's all ready. And now I've reviewed it, I've checked it, I'm happy for it to be merged back into the main branch. So now we're just going to quickly show you how to do that.
And it's very simple. We simply say git merge Sam's branch. And
you're missing the S.
Sorry?
You were missing
yep,
the S after
absolutely.
Sam's.
Yep, there we go. And so we've merged it, and then we git push origin Sam's branch. Fantastic.
Cool. And now we have merged that branch back in, and now the files that are in there are going to be in the master branch.